There are places in the universe where the fabric of reality is torn apart. Places where time stretches, space collapses, and the laws of physics completely break down. A place where even light cannot escape. These are black holes, the most terrifying and powerful objects of existence. But what if I told you that black holes are not just cosmic monsters? Could they be gateways to something beyond our understanding? Tonight, we embark on a journey into the unknown. We will witness the birth of a black hole, see how they grow to immense sizes, dive inside to observe the chaos within, and answer the ultimate question. Could black holes be the key to unlocking the deepest secrets of the universe? Everything starts with a star, a celestial giant burning with the fury of billions of nuclear bombs, converting hydrogen into helium, constantly battling against gravity. But what happens when this battle is lost? When a giant star reaches the end of its life, it runs out of fuel. Without fuel, there is no more energy to push outward. Gravity, held at bay for millions of years, finally takes over. And then, the inevitable happens. A dying star extinguishes itself in one last explosion, a supernova. For a brief moment, it shines brighter than an entire galaxy. But at its core, something terrifying is forming. A singularity, a point of infinite density where the laws of physics collapse. And then, darkness. But wait, how do we know this happens? If black holes trap even light, how can we see them? When a black hole is born, it doesn't just sit there. It is hungry. And this hunger is endless. As a black hole moves through space, it consumes matter, gas, dust, even entire stars. Anything that gets too close is doomed. But this is where things get even stranger. Matter doesn't fall in silently. Instead, it spirals around the black hole in a violent, bright storm. This is called an accretion disk. These disks can outshine entire galaxies. Some black holes even eject energy jets into space at nearly the speed of light. But wait, black holes are supposed to swallow everything. So, why do some of them spit energy back out? What if we go deeper? What if we fall inside? As we cross the event horizon, the point of no return, something strange happens. Time itself slows down. To an outside observer, we seem frozen at the edge, forever. But from our perspective, we keep falling, deeper and deeper. This is where the laws of physics collapse. At the singularity, gravity becomes infinite. Space itself bends into nothingness. The fabric of reality unravels. But the biggest mystery remains. What happens next? Does everything disappear? Or is there something beyond the singularity? Not all black holes are the same. Some are small. Some are monsters. In this chapter, we explore the 4 types of black holes known to science. Each plays a different role in shaping the universe. Stellar black holes, cosmic graveyards. The most common type of black hole is the stellar black hole, the direct result of a massive star's death. Size, 5 to 100 times the mass of our Sun. There are millions in the Milky Way alone, but most are invisible, detected by their gravitational effects or the X-rays emitted by matter falling into them. Example, Cygnus X1, one of the first stellar black holes ever discovered, located 6,070 light-years away, orbiting a giant blue star. Detected by the X-rays emitted as it devours matter from its companion star. But stellar black holes, as big as they seem, are nothing compared to what comes next. Intermediate mass black holes, the cosmic missing link. For years, astronomers struggled with a puzzle. Why were there only small stellar black holes and enormous supermassive black holes, but nothing in between? Intermediate mass black holes fill this gap, ranging from 100 to 100,000 solar masses, formed in dense star clusters from multiple star collisions. Some scientists believe IMBHs are the seeds of supermassive black holes. Example, HLX-1. Found in a distant galaxy 20,000 times the mass of the Sun. Might be the black hole from a once-destroyed dwarf galaxy. But if intermediate black holes are just seeds, what happens when they grow out of control? Supermassive black holes, the hearts of galaxies. At the center of nearly every large galaxy, something so massive, so powerful exists that entire star systems orbit around it. Supermassive black holes range from millions to billions of solar masses, responsible for shaping galaxies and influencing their evolution. Example, Sagittarius A, the supermassive black hole at the center of the Milky Way. Mass, 4.3 million suns. First ever imaged by the Event Horizon Telescope. If Sagittarius A is impressive, the next category will leave you in awe. The giants, ultramassive black holes. What happens when a supermassive black hole grows beyond all limits? Some black holes reach tens of billions of solar masses. These ultramassive black holes defy our imagination. Example, Ton 618 mass, 66 billion suns, could swallow our entire solar system in an instant. So massive it bends light around it, creating the ultimate void in space. But now, let's compare the most famous black holes ever discovered. Sagittarius A, the silent giant. Mass, 4.3 million suns. Distance from Earth, 27,000 light years. Despite its size, it is relatively quiet and rarely consumes large amounts of matter. M87, the cosmic titan. Mass, 6.5 billion suns. The first black hole ever photographed, 2019. Feeds a massive relativistic jet, ejecting matter at nearly the speed of light. Ton 618, the ultimate devourer mass, 66 billion suns. The largest black hole ever discovered. Its event horizon is over 1,300 astronomical units, larger than our entire solar system. Black holes might seem like the end of everything, but what if they are actually gateways to something greater? Some scientists believe black holes could be connected to white holes, objects that expel matter instead of swallowing it. If true, this would mean black holes don't destroy matter, but transport it somewhere else. But where? Another universe, a different dimension. And what about the Big Crunch theory? Could the entire universe collapse into a black hole? In the end, black holes may not be destroyers, but the architects of something far greater. We came in search of answers, but we found even more questions. What lies beyond a black hole? Could they be the key to time travel or new universes? For now, the answers remain hidden in the depths of darkness.